Amazing students. We are now going to move on to our second type of application problem with rational equations. And these are all about distance, rate, and time, which they're going to be awesome. These are fun times and you guys are going to have a blast. And these should only be for the honors students. So if you're not in honors, you can technically watch the video and learn how to do these, but it is not required. All right, so example one, or first of all, before we get started, our time equation, time equals distance over rate. You guys probably already know the equation distance equals rate times time. So where I got this from was I solved it for t. So I just brought my r to the other side and kind of rearranged things. So these canceled out, so you were left with time equals distance over rate. Okay, so that's where that equation came from. All right, and our equation we're going to be focusing on today is our total time. So something's going to be going on, okay? And it's going to take a total amount of time for this person to get whatever they're doing done. Okay, so that's our big T. So our total time equals the time it takes upstream or against some sort of force. So against the current, against the wind, something of that sort. Plus the time downstream, or the time with the current or with the wind, etc. Okay, now where these came from. Okay, so we know that time equals distance over rate. So for our first time, I just made it right here. So time equals distance over rate. So our first time is going to be the distance 1 over rate 1. I cannot talk today. Okay, because that is our first time. And our second time will be our second distance over our second rate. So that's kind of where these are coming from. So if that doesn't really make sense, just know that this is the equation we're going to be using today to conquer these awesome problems. So get excited, you guys. All right, let's dive into our first example problem. So example 1 says, a kayaker spends an afternoon paddling on a river. Do you go kayaking? I do. It's so much fun. I highly recommend it if you've never done it before. But anyways, she travels 3 miles upstream and 3 miles downstream. So she's going upstream 3 miles and downstream 3 miles, which whenever you kayak, that is kind of how you should always do it, because it's a lot easier to go downstream than upstream. So if you do all the work up front, it's much easier at the end if you go with the current. So just kind of keep that in mind if you ever choose to go kayaking. But anyway, so she travels 3 miles upstream and 3 miles downstream in a total of 4 hours. Okay, in still water, so this means without any current, okay, the kayaker can travel at an average speed of 2 miles per hour. Okay, so that's the rate that they are traveling at. Based on this information, what is the average speed of the river's current? And we're going to round our answer to the nearest tenth of a decimal. Okay, so we are focusing on the current. Okay, so eventually I want to figure out how fast the current is going to make this kayaker take 4 hours to go 3 miles upstream and 3 miles downstream. Okay, so in the problem, the current I'm going to identify with the variable c. Okay, so this right here I will represent with the c. Okay, so we're going to focus on the upstream information, because that's all going to go here, and the downstream information, because that's all going to go here. And then we need to find out what the total time is, which I have that down here. Okay, so let's see here. A kayak spends the afternoon on a river. She travels 3 miles upstream and 3 miles downstream. Okay, so 3 miles, is that a distance or a rate? You guys are so smart. That is a distance. So the distance that they are going upstream is 3 miles upstream. So that pertains to upstream stuff. So all this stuff, you guys, I'm going to do in orange. Remember, I like to color code stuff. So this fraction, all the information for this will be in orange. Okay, and this is a distance, you guys. So this is going to be my distance 1. Okay, so the distance for the upstream is 3, but also they go the same amount downstream. So 3 miles downstream. So everything that's downstream, I'm going to do in blue. So for my 3 miles downstream, this will be a D2 for my distance. Okay? So in my chart, you guys, I just have this to help organize our information. Eventually, we are going to put this into a fraction, though, which that's what we're going to write right here. So get excited. Okay, so 3 miles downstream and 3 miles upstream in a total of 4 hours. So which one of these would be the total amount of time they spent on the river? You guys are so smart. It is our big T. So big T is going to be 4 hours. 4 hours. All right. It says in still water, the kayaker can travel at an average speed of 2 miles per hour. Okay, so that's going to kind of go in our rate category, but the rate is going to be influenced by the current, so you got to wait for that. Okay, so far, the rate, no matter which way the kayaker is going, you guys, they can paddle at this rate. Okay, so 2 miles per hour. Okay, so upstream, they can go 2 miles per hour, and downstream, they can go 2 miles per hour. Okay, so this one's kind of a joint thing, so I'll kind of do it in both colors. Kind of looks cool, doesn't it? All right, and this is going to be a part of our rate for each piece. Okay, now, the current of the river is going to influence how fast this person goes upstream and downstream. And in our equation, you guys, we want to know the time, okay? So our time is influenced by this sneaky little current in the river that is influencing how fast they can go. Okay, so we need to incorporate the current somehow into this problem. Okay, so if we think about it, when you go upstream or downstream, like I said earlier, it is a lot harder to go upstream because you're battling the current. So the current's going this way and you're trying to paddle this way, and it's not working out because you're having to paddle against this current that's pushing against your kayak. Okay, so we need to add or subtract the current to the upstream and the downstream. So if we're going upstream, since it's harder to fight the current, if this is my kayaker, it's harder to fight this current because they are opposing each other. Okay, so our overall rate, do you think that would be faster or slower than this 2 miles per hour if we're having to fight this additional current? You guys are so smart. It would be slower. Okay, our rate is going to be slower when the 2 miles per hour the kayak is going is affected by this current it's going against it. So if we are trying to add or subtract a current to the rate, we need a smaller value for our rate. So if I take out if I'm opposing the current to get a smaller rate, I would need to subtract it. If I subtract something from a number, it is a smaller number, which means we're traveling at a slower rate. Okay, the opposite occurs with downstream. When you're going downstream, so say this is my kayaker, it's going downstream. Okay, the current is going with it. Okay, and it's actually going to be pushing the kayaker, so it's actually going to make the kayaker go faster. Okay, so our rate needs to be a larger number than this 2 because the 2 miles per hour is getting pushed by the current. So the way we make a number larger is by adding something to a number. So our rate is going to be 2 plus c. Pretty cool, right? All right, so now we need to build our fractions. So we're going to put our distance and divide it by our rate. Okay, so all I'm going to do is take my distance values and divide it by my rate so I know what these values will be in my nifty equation. So distance over rate, so I'm going to put my 3 over my 2 minus c in this first one. So 3 over 2 minus c, and downstream will be almost the same, but my rate's a little different. So 3 over 2 plus c. Voila! All right, guys, so now I've got the fraction for this right here, our time upstream, and I have the fraction for our time downstream. So again, this is our time downstream. Time downstream. And this is our time upstream. Okay. All right, so let's set up this equation now that we have all of our information together. So our total time, that's our 4 hours that the kayaker is kayaking. So we're going to have 4 equals, all right, our time upstream, which the time upstream is this first fraction, so 3 over 2 minus c. And then plus our time downstream, which is this 3 over 2 plus c. Say what, right? So plus our time downstream, which is 3 over 2 plus c this time. All right, guys, and then from here, it's just a normal equation. So we're going to solve this like we would any other rational equation. So we have our LCM and our undefined, like normal, which I was kind of interfering with my LCM. So my LCM I might kind of write over here since I kind of ran out of space. So we have to find the LCM first, and then remember we take the LCM and we must figure out where it's undefined, which is very important, you guys, because when we have word problems, only certain values make sense. Okay, so the undefined really is important when you have word problems. All right, so our LCM, if I grab one of every single factor from my denominator, my LCM would be made up of my 2 minus c and my 2 plus c. So that would be my LCM. So 2 minus c times 2 plus c. Yay, so that's my LCM. And the undefined, we just set each of these bad boys not equal to 0. So I'm going to have 2 minus c cannot equal to 0. And I'm going to have 2 plus c cannot equal 0. And then we're just going to solve this thing for undefined. All right, so the way I solve this thing, I got to get c by itself. Okay, so probably the easiest way to do this, you guys, since my c is negative, probably the best way would just be to move c to the other side. And then we would be done. You don't have to do it that way, though. If you want to bring the 2 over first and then deal with the negative c, you can do that too. So I'm going to add my c to the other side, which negative c plus c cancels, turns to 0. So I'm left with 2 cannot equal 0 plus c is c. So one of the values that is not allowed is 2. My other one, since my c is positive on this side, probably the easiest way to solve would be just to bring my 2 over. So I'm going to subtract my 2 on both sides, which 2 minus 2 cancels and turns to 0, and 0 minus 2 is negative 2. So the other value that is not allowed is negative 2. So I have to be on the lookout for 2 and negative 2 when I solve. Which honestly, you guys, does negative 2 even make sense for a current value? Remember, our c is current. Can current be a negative rate? No, we can't really have negative rates. So this one doesn't even make sense anyway. So if we get a negative answer, it shouldn't even work out. Okay? All right, guys, so let's solve our awesome equation. So remember, the first thing we do when we have an equation is we take our LCM and we multiply it to every single numerator in the problem. So that's all I'm going to do. So I'm going to say 4, going to leave a little space for my LCM, and then 3 over 2 minus c plus 3 over 2 plus c. All right, let's multiply by this LCM up here. So I'm going to multiply by 2 minus c and 2 plus c to every single numerator. Let's see what happens. So 2 plus c, 2 minus c. Sorry, guys, I didn't leave enough space. Make sure you try to leave enough space for that. Okay, and then 2 minus c times 2 plus c. And then 2 minus c times 2 plus c. All right, let's start crossing out our fractions. So remember, the goal of equations, you guys, is to try to get rid of the fraction. That is the goal. Okay, so let's see what happens. Okay, so this first one, nothing's going to cross out. So I'm going to move on. This one, the 2 minus c's will cross out. Bam. And I'm left with 3 times 2 plus c. So I'm going to write what I'm left with down here. So I have 4 times 2 plus c times 2 minus c equals, I have this 3 left, so it's going to be 3. And then I have this 2 plus c left, so 2 plus c. Plus, let's see what cancels out here. My 2 plus c's will cancel. So I'm left with 3 times 2 minus c. All right, so then after this is just a bunch of algebra. A lot of multiplying, a lot of dividing, etc. Okay, so I'm going to shift this up here, which I'm going to kind of block off some space so we don't get things confused. Okay, I'm going to shift this bad boy up here and keep going. All right, so let's deal with this first. So first, before I deal with this 4, I have to distribute all this stuff out. Okay, so I'm going to write the 4 first, and I'm going to relieve whatever I get after I distribute in a parenthesis. Let's see if I can fit it. Okay, so let's start here. I'm going to start distributing. So 2 times 2 gives me a 4. 2 times negative c gives me a negative 2c. C times 2 gives me a positive 2c. And my c times negative c gives me a negative c squared. Bam. I fit it, yes. Okay, and I'll zoom in so you guys can see that a little better. All right, let's keep on going. All right, and then over here, Sorry guys, I was supposed to focus it. Definitely didn't focus it. Jeez, Ladybug. There we go. Okay, so now I'm going to start over here, and I have to distribute the 3 to both of these and the 3 to both of these. So let's go. So 3 times 2 will give me a 6. So this equals 6. And 3 times c gives me a plus 3c. And same on this side. I got to distribute this thing. So 3 times 2 gives me a 6. And 3 times negative c gives me a negative 3c. Holy hot dog. Alright guys, so same thing here. I have a number outside of a parenthesis, which means I need to distribute. But before we do that, why don't we combine our like terms? Because I'm seeing that something might cancel out. So if I'm looking here, the only like terms I see, you guys saw it too, my negative 2c and my positive 2c. So negative 2c plus positive 2c will cancel out. Those bad boys cancel each other out. Bam. So now what I'm left with is 4 times 4 minus c squared. Bam. All right, and I might as well combine some like terms over here. So let's see here. What are my like terms? Do you guys see here my c's? So I have my 3c and my negative 3c, but guess what, you guys? Those also cancel out. Bam, bam. So all I'm left with is 6 plus 6, which is 12. Awesome. All right, let's keep going. I got a number outside of parentheses, which means I need to distribute. Or if you guys want to, actually a faster way to get this stuff done, you could also bring the 4 to the other side. Since it's secretly multiplying, if you didn't want to have to distribute, you could just divide. So either way. So I'm actually going to do that because I think that will make my life a little bit easier. So I'm going to divide each side by 4, which 4 divided by 4 cancels. So I'm left with 4 minus c squared equals 12 over 4, which is 3. All right, let's keep on going, keep on going. Okay, so I'm going to bring my 4 to the other, well, that's kind of tricky. Because I don't really want to deal, well, I guess it doesn't matter. Sorry, I'm talking to myself, thinking out loud. Sorry, guys. Let's just bring the 4 over. Might as well, right? So the way we bring 4 to the other side, the opposite of positive 4 is negative 4. So I'm going to subtract that thing, which 4 minus 4 cancels, turns to 0, and 3 minus 4 is negative 1. Okay, so I'm going to keep going over here. So I have a negative c squared equals negative 1. All right, and there's secretly a negative 1 in front of my c squared. So the way we move that over is by dividing by negative 1, which these will cancel and turn to 1. So I'm left with c squared equals negative 1 divided by 1 is 1. All right, guys, I'm so close. I'm so close. We're almost there. All right, I need to undo this squared. The way we undo a square is a square root. You guys are so smart. Square root that thing. Okay, which the square root cancels out my squared. So I'm left with, I'm running out of space. Okay, so I'm going to write my answer up here because we're going to have to talk about one thing. So I'm left with c equals, okay, remember we square root both sides. Technically, a plus or minus should pop up. All right, and the square root of 1 is 1. But let's think about this and if this even makes sense. Okay, so this is saying my current, or the rate of my current, is a positive 1 or negative 1. One of these answers does not make sense. You guys are too cool for school. The negative 1 doesn't make sense. You can't really have a negative rate, you guys. So technically, the only one that makes sense is my positive 1. So my current is traveling at 1. And remember, we must include our units, which, if we look back at our rates units are in miles per hour. So the rate of the kayaker is the same as the rate, or the units for the kayaker's rate is the same as the units for the river's current rate. Okay, so my units are miles per hour. Remember, I must see these units in word problems, or your answers are nasty and naked and gross and disgusting, and I don't want to see them. Okay, so our final answer is 1 mile per hour. But technically, before I circle this, I need to check back at my undefined. Okay, the only values that are not allowed to work are 2 and negative 2, which I didn't get either of those. So yay. So the rate of the current is simply 1 miles per hour. Oh man, you guys, that was a lot of fun. Next time you go kayaking, I know you're going to be doing this math in your head while you kayak because you want to figure out the rate of the current. I know you do. All right, guys, that was awesome. We'll be starting example 2 in just a moment.